All right, had a little bit of issues with technology, so I'm going to start by going over solving with square roots. This is really the completing the square process. And so when do we use completing the square? We're going to want to know this process to solve a quadratic equation for when you cannot factor a trinomial. So let me show you an example. This is the full completing the square topic right here. And so we start with this example, x squared minus 8x plus 17 equals 0. And so 17 is prime. So you initially start with your factoring, and the factors of 17 are 1 and 17, which make 18, and that's it. And that's not the same as negative 8, that's 18. It's totally different. So that means that this is prime in terms of it does not factor. And so what we're gonna do is follow this whole process. I'll show it to you here. We're gonna first get rid of this 17. It doesn't work, but we can use the 8. And so we'll be able to kind of adjust this problem into something that we can solve. Now what's important is that this is x squared and that this is even, okay? So we use completing the square when a is equal to 1 and b is equal to an even number. If it's not even, then I'll look at another method in our next set of notes. So now that it's moved, we're going to add something special to both sides. This number this time is 16. The formula for this new c is the b value divided by 2 and squared. And this is equal to the special c. So in this case, 8 divided by 2 would be 4. 4 squared is 16. Now that it's 16 here, 4 plus 4 is 16 and 4 plus 4 is 8. But since this is the negative 8, that means that we can factor this to the special pattern of x minus 4 to the power of 2. Negative 17 and 16 are going to make negative 1. After that, we see that this is a square power, so you can already see that the next thing to do is to take the square root of both sides. And here you're saying, oh no, the square root of a negative, that's very strange. That's true, it's totally strange. The square root of negative 1 is equal to the letter I, and the square root and the square power canceled each other out, so then we don't need to use the parentheses. When we're taking the square root, we're always going to put the plus and minus symbol in front, and anytime there's a square root of a negative, I will be in the answer. If it's just negative 1, the answer is I, but if it's anything else, it might be I times that number. And now we're at the very end, we're going to get rid of the minus 4 with a plus 4. Because the 4 doesn't have an I, that means that I is going to be its own term, and so the answer will look like this. 4 plus or minus I, which has the meaning of 4 plus I and 4 minus I. And then here's the little hint for factoring it. So this is the whole process. We have a little acronym to help you remember, CBD2S, CBD2, and then I'm supposed to put P for parentheses. So this is CBD2S, means move the old C. Then we take the B divided by 2 and squared. That's the special value that we add. And then it's F for factor, BD2PS. So you factor to B divided by 2 parentheses squared. So that was our first example of completing the square. Just as a little hint to you, these are what all of the perfect square trinomials look like. So if it's a 2, that means it's x plus 1 squared, and we need 1 here. For 4, it's kind of tricky because it's 4 again, because 2 times 2 is 4, and 2 plus 2 is 4. For a 3, we'll have 6. 3 plus 3 is 6. 3 times 3 is 9. If there's an 8 in the middle, that's x plus 4, and we need 16. We just saw that one. For 10, that's gonna be 5 plus 5, and then 5 times 5. 6 plus 6, 6 times 6. 7 plus 7, 7 times 7. 8 plus 8, 8 times 8. So it's the number doubled in the middle and then multiplied by itself at the end. And so if we have it like as a pattern like this, right, it's the number squared and 2 times the number. Or with the letter y, it's 2 times the letter y with x and then y squared. So here's a little bit of work with the square roots. So if it's x squared minus 16, just as a reminder, we solve that like normal by adding 16 with the square root. With square power, we take the square root of both sides and we get plus and minus 4. But if it was x squared plus 16, we would do that same work, but this time it's subtract 16. And when you take the square root of a negative, wow, that's something new. That's a negative, and so you're seeing, oh, that's going to create, the square root of 16 is 4, but because it's negative, we put the I at the end, just like we saw in the last one. So here's another one. If you try this one, x squared plus 20. Well, this one is going to be more complicated. We're going to subtract the 20. Then we're going to take the square root, but 20 is special. So give it a try. Subtract the 20. We take the square root. But then see how I'm going to rewrite 20 as negative 1 times 4 times 5. So this is the imaginary part. Then we break it into a perfect square part. And then this is my leftover part, 5. 4 is a perfect square. It's 2 times 2. So then this becomes plus or minus the square root of 4, 2. The imaginary number from the negative, and then the rad 5, which didn't get used up. It's important for the notation that I goes in between the number and the radical. We don't want to put I on the inside. We always want to put I on the outside and in front of a radical, just so that it's really clear. Here's another one. So here when I have this one, x minus 3 squared, well, right away, just like these ones, it's just something squared. We take the square root. You can see that this is negative 12 when we took the square root. 12 again has a who inside of it? A 4. So then we're going to rewrite this one as negative 1 times 4 times what to make 12? 3. So you can see that this one becomes 2I rad 3. And then when we add the 3 to both sides, it does not have any like terms with this. So this will be a binomial answer that looks like this. 3 plus 2I rad 3 or 3 minus 2I rad 3. And that's it for completing the square. That's a very brief notes, but hopefully it gets you started. The formulas that you again want to remember is that it's, you move the old c, then b divided by 2 squared, which is just b divided by 2 squared. That's the new c. And then to factor, you take b divided by 2 parentheses squared. So that's x plus b divided by 2 parentheses squared. These are the two big ideas. So you're going to have to remember the BD2 and the BD2. PS for parentheses squared and just S for squared. This is the C and this is the factoring. Good luck. Come in if you have any more questions. I'd love to help you. I know it's a bummer that the video didn't save.